Hello! In this video I'm going to be going over Lewis dot structures, individual elements and of molecules, and we'll be looking at symmetry and whether it is polar or non-polar. Alright, so first of all, quickly doing some basic examples. Let's say we have hydrogen. Hydrogen has how many electrons? Well, this periodic table right here, hydrogen is in column 1, so it has 1 outer electron. So we're going to show that by 1 dot. Lithium, same thing. First column, so it has 1 outer electron. Same thing with sodium, 1 outer electron. Well, what about something like beryllium? Beryllium, Be, has, it's in the second column, so it has 2 outer electrons, so we're going to write 1, 2. I always just start at the top and then go clockwise. You can start at the side, go clockwise. It doesn't really matter at this point. Just know that there's 4 sides, top, bottom, side, inside. If we do magnesium, it's right here, you're going to have also 1 and 2. Let me get a periodic table on the computer so it's easier. Alright, like magic, there's that periodic table. And we were moving right along. We're not going to do these transition metals. It gets too complex because they have multiple charges that are formed. So we're going to go right and just stick with the block A elements. So here we got 3A, also known as column 13. These guys have 3 outer electrons. So an example would be like boron or aluminum. Boron would be 1, 2, 3. Aluminum, again, 1, 2, 3. Moving on, carbon is in column 4A or 14. Has 1, 2, 3, 4 outer electrons along with silicon. 1, 2, 3, 4, and so on. And then nitrogen, 5A, also known as column 15, has 1, 2, 3, 4. Now we can pair them up, 5. And phosphorus would be another example, 1, 2, 3, 4, 5. Alright, moving on to oxygen, column 6A, 1, 2, 3, 4, 5, 6. It has 2 lone pairs and 2 bonding sites. Lone pair is a pair of electrons that will not be involved in bonding. Fluorine is number 7. 1, 2, 3, 4, 5, 6, 7. Bromine is in that column also, right over there. And that has 1, 2, 3, 4, 5, 6, 7. So basically, all of these elements in this column have 7 outer electrons, and then the noble gases have 8, which is why they are inert. They do not bond very much. Let's say they have an expanded octet because they are satisfied. They have 8 outer electrons. Another one would be neon, 1, 2, 3, 4, 5, 6, 7, 8. However, helium is an exception. So just about every rule that chemistry has at least one exception to it. Helium just has 1, 2 outer electrons. And the reason that is because it only has 2 electrons total. The lowest energy level is the S energy level, and it has a max of 2 electrons. So it is unique in that sense. Alright, moving on to a more difficult problem. We have O2. So this means we have 1 oxygen and another oxygen, 2 oxygens. An oxygen is in column 6A or 16, so it has 6 outer electrons. So we're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now all of the single electrons are the ones that are going to be involved in bonding. They're going to connect. So right here they connect, and right here they connect. Because now we have a covalent bond happening, meaning these electrons are being shared between both of these atoms so that they can both have a satisfied octet. We have 1, 2, 3, 4, 5, 6, 7, 8 on this oxygen, and 1, 2, 3, 4, 5, 6, 7, 8 on this oxygen, and they're both satisfied. And it looks a little sloppy that way. When you get good at it, you can kind of anticipate how to draw it. although I will accept this, that is correct. If you want to make it look pretty, you do something like this. Yeah, it looks nice and pretty. You know. But this is also acceptable. Alright, then we have to ask ourselves a question. Is it symmetrical? Because the symmetry will tell us whether it is polar or non-polar. Alright. This guy, if you can cut it in half this way, and you can cut it in half this way, and it's equal on both sides, say yes to both, then it is non-polar. So, yes, symmetrical. So therefore, non-polar. If it was not symmetrical both ways, then it would be polar. Alright, doing another example, let's do CO2. So we have more than 2 atoms now. Whenever you have more than 2 atoms, then what you're going to have to do is put the one that's in least supply in the center. Or if you have carbon, carbon is always in the center. What if you have 5 carbons? Then all 5 carbons are in the center. Although probably won't have any situation like that in this class. Maybe in organic chemistry. Alright, carbon is in the center, and it has 4 outer electrons because it's in column 4A or 14. And oxygen, I'm going to put 1 on each side because usually symmetry happens. And this guy has 6A, so it's 6 outer electrons. 1, 2, 3, 4, 5, and I'm going to put the 6th one over there so the picture will look prettier. 1, 2, 3, 4, 5, 6. Make that darker. Alright, now you connect the single dots. So we got a single dot there, 2 single dots there, single dots, and it looks like we have 2 double bonds. Each line consists of 2 electrons being shared, 1 from each atom. 2 lines is 4 electrons, and if you have a situation with 3 lines, it would be 6 electrons being shared. So in looking at this, we got to ask ourselves, is it symmetrical? I would say yes, it certainly is symmetrical. If you cut in half both sides, it's going to equal the same thing. So this is non-polar. Alright, doing another example, let's do H2S. So this one has 3 atoms again, however there's one that's in least supply. That's going to be the center one, which is sulfur. And sulfur has, well, it has 6, right? It's in the oxygen group 6A. So it has 1, 2, 3, 4, 5, 6. And then we're going to add the hydrogens to the bonding sites. 1 hydrogen because it's in column 1. And they bond like that. So now, if we cut this guy in half both ways, is it symmetrical? The answer would be no, it is not. So therefore, it is polar. Well, you could say, what happens if I write it like this? This certainly looks symmetrical. However, we're going to talk about in a little bit, not in this video, but in another video, when you have a certain amount of lone pairs and terminal or outer atoms, that's going to determine the shape. And the shape is what you look at, really, to determine whether it's polar or non-polar. And this is one of those weird ones where you have to know Vesper theory in order to really be able to know that this is not symmetrical and it's polar. So it should be written like this. That's the correct drawing. That'll make sense a little later on. Alright, let's do another one. So we got CH2O. There's 2 that are in least supply, carbon and oxygen. If you have a situation like that, carbon is always in the center. Alright, so I'm going to draw a carbon right here. And it has 1, 2, 3, 4 outer electrons. It's found right here on the periodic table, 4A. And I'm going to put oxygen on one side, which has 6 outer electrons. 1, 2, 3, 4, 5, 6. And I have 2 hydrogens I'm going to put on this side. And it has 1 outer electron. Then I'm going to connect the dots, single dots. Those can connect. and those can connect. And this guy, if you cut it in half, it's certainly not symmetrical because you got oxygen on this side, hydrogen's on that side. That's not symmetrical. So we would write no, and therefore it would be polar. Alright, doing another one. We have CH4. Carbon has 4 outer electrons because it's in column 4A. And we have 4 hydrogens. I'm going to add them on each side. 1, 1, 1 for each, and they're going to bond. We got a nice little shape. This guy is symmetrical both ways, so we write yes. And if it is symmetrical, it is non-polar. That's methane. Alright, another one. We have NH3. Nitrogen's in least supply. We put that in the center. It's in 5A, so it has 5 outer electrons. 1, 2, 3, 4, 5. And we have 3 hydrogens. And each hydrogen has 1 outer electron. Connect, connect, connect. Alright, is this symmetrical? The answer is no, because you have a lone pair on the top and a hydrogen on the bottom. So that is not symmetrical. And if it's not symmetrical, it is polar. Alright, just for fun, we'll do one more. Let's skip down to CF4. Carbon is in the center. It's always in the center. It's also the one least supply. And it has 4 outer electrons, and it's bonded to 4 fluorines. And fluorine, remember, is a halogen which has 7 outer electrons located right here in the periodic table. And 1, 2, 3, 4, 5, 6. I'm going to put 7 over there so the picture is pretty. It can bond nice there. 1, 2, 3, 4, 5, 6, 7. They're going to bond. 1, 2, 3, 4, 5, 6, 7. They're going to bond. 1, 2, 3, 4, 5, 6, 7. And they're going to bond. And you cut it in half both ways. It is symmetrical. Yes. Therefore, it is non-polar. Alright, so those are just a few examples. With this, it's practice, practice, practice makes perfect, perfect, perfect. Hope you enjoyed. That was Lewis dot structures of covalent molecules.